Renewable energy refers to processes that allow energy to produce at least as fast as it's consumed. Therefore, the resource is not being used up in the process of doing work. These sources include wind, solar, geothermal, which is energy from the heat of the core of the earth, hydropower, and biomass, which is energy from plants. Almost 20% of Canada's total primary energy supply comes from renewable resources, making Canada a world leader in the production of renewable energy. The use of biomass as an energy source is not very sustainable, as it often includes burning wood for fuel, which is a combustion reaction which produces carbon dioxide. Geothermal energy can be used in places where the geothermal gradient is high. This means that the heat from radioactive decay at the core of the earth is close enough to the surface that it can be used as energy. This is limited to a few places on earth. Heat stored in the soil or the surface of the earth can also be used as energy, as soil maintains a relatively constant temperature independent of the time of year, which can be used to heat buildings, but not as a source of electricity. The use of wind and solar photovoltaic energy are increasing at the fastest rate around the world. Solar photovoltaic energy works by converting direct energy from sunlight into electricity. So these are the solar panels that are commonly seen on rooftops, and they're often made from silicone, which is a semiconductive material. On the top side of the silicone panel, phosphorus is added, giving it a negative charge, and on the bottom side of the panel, boron is added, giving it a positive charge. When the electrons in the silicone atom absorb a photon of light energy from the sun, they are separated from their silicone atom, where they create an electrochemical gradient, which can be trapped by metal plates and then in wires to produce electricity. A disadvantage of this method is that it only works when the sun is shining, so during the daytime and when the weather conditions permit. Wind energy uses the kinetic energy of moving winds and converts it into mechanical energy by spinning turbines, which can then be used as electricity. Wind is a renewable free resource, and it does not cause pollution, nor greatly impact natural wind patterns. But a drawback is that the amount of energy produced will fluctuate with the strength of the wind. So, on to the first issue. Hydroelectric power is by far the leading source of renewable energy around the world. Electricity generated by hydroelectric stations produced almost 60% of Canada's electricity. This process works by converting the kinetic energy of falling water into electrical energy by spinning a turbine, which rotates a magnet inside of a generator to produce electricity. Dams are built to store more potential energy of water, and then it can be released whenever energy is needed. However, dams can cause adverse environmental impacts, such as the disruption of natural water flow and the flooding of surrounding areas to make reservoirs. So the ecosystem downstream can be affected, the oxygen levels in the water can be affected by low water flow, as well as the wildlife habitats can be affected by sediment, which is caused by artificial flow patterns. So it can have a negative impact on these animals. A way to limit this issue is to install fish ladders, which allow the fish to migrate away from the dam. Another consideration of building a dam is the flooding of the surrounding land, which would cause animal and human species living in that area to be dispersed, as well as the death and decay of organic matter. So when plants and organic material decay, methane and carbon dioxide are released by microorganisms that break down these materials. Mercury is naturally occurring in sediment, and it has toxic effects on the human central nervous system. In an anaerobic environment, bacteria can produce methylmercury, which can then bind to muscle cells in fish and the surrounding area. So fish in hydroelectric reservoirs have been found to have higher levels of methylmercury, which can impact humans who eat these fish in this area. Hydroelectricity can also be produced without the use of a dam through a run-of-the-river system, where kinetic energy from moving water is used to power a generator. However, there's less control of when and how much energy can be produced in this way. So although there are disadvantages to hydroelectric power, especially when it involves a large dam, there are still many advantages as it provides an alternative to burning fossil fuels in a renewable, free way, and it does not cause great amounts of pollution. Hydrogen fuel cells also make use of an abundant natural resource by converting the chemical energy found in molecular bonds into electrical energy. Proton exchange membrane, or PEM cells, are one type of hydrogen fuel cell that uses hydrogen and oxygen as fuel, which produce only water, electricity, and heat as byproducts, as opposed to the harmful products produced by nuclear energy and the burning of fossil fuels. So a PEM cell consists of the anode, where oxidation of hydrogen occurs to produce 2 protons and 2 electrons per each molecule of hydrogen gas, and a cathode, where the reduction of oxygen occurs using the products of oxidation to produce water. Energy is generated in this way because the proton exchange membrane in the center only allows protons to flow through, not the electrons. The electrons therefore travel through an external circuit where they can be used to do work before they combine with the oxygen at the cathode to produce water. There's also a catalyst, which is usually made from small particles of platinum embedded into carbon, and it allows these reactions to occur. Hydrogen fuel cells are efficient because they convert the chemical potential energy directly into electrical energy without losing as much energy through heat, as is the case for combustion engines. As the oxygen in the fuel cell is gained from the atmosphere, the cell only needs to be provided with hydrogen to function. This hydrogen can be produced in various ways. Currently, the cheapest way to produce hydrogen is breaking hydrocarbons using hot steam, which is known as hydrocarbon reforming. This method still requires the use of fossil fuels and produces greenhouse gases, so it's not a very sustainable method for the future. Other ways to produce hydrogen include electrolysis, which is splitting of water molecules into hydrogen and oxygen. But this method is very energy intensive and costly. However, if the energy needed for electrolysis can be gained from other renewable resources such as solar, wind, or geothermal, I believe this is a clean alternative to burning fossil fuels. Other methods for producing hydrogen include photolysis, in which blue-green algae are breaking seawater into hydrogen and oxygen, provided with the correct temperature and pH conditions. This process is environmentally friendly and does not require external energy. Fuel cells have been used by NASA for electricity as well as a water source for many years. Recently, there have been major advances in fuel cell vehicles, with an article from 2015 claiming that every major car company is in the process of developing a fuel cell powered vehicle. There is still much work to be done in regards to safety, as hydrogen is highly flammable and the transportation of hydrogen to fueling stations may be an issue. However, hydrogen fuel cell powered vehicles offer a promising alternative to fossil fuels. So in conclusion, although many alternative energy sources and renewable resources are currently very costly, the transition from our traditional use of fossil fuels to more renewable resources can provide many job opportunities in the building and maintenance of new infrastructure. Thank you.